Welcome everyone. My name is Peter Noorderijk. It's a typical Dutch name, and as you can imagine, I'm from the Netherlands. It's an honor for me to present this webinar, and in this webinar I will talk with you about some improvements and new features of HyperV in Windows Server 8. I am 30 years old. I'm working in IT since 2002. I started as an all-around system administrator in the small and medium-sized business, and I'm grown to senior infrastructure consultant and architecture for virtualization and messaging solutions in the Microsoft IT environments. Since February this year, I'm co-owner and architect of Imara ICT. Imara means solid in Swahili, and so that's where we stand for at Imara. As Ron just said, I'm one of the persons behind the HyperV community in the Netherlands, and you can read our blogs at www.hyperv.new. And we are blogging about Microsoft virtualization solutions such as HyperV, but also System Center solutions and other management solutions for HyperV. We are blogging in English, so it's also interesting content for you guys. You can also follow me on Twitter, and my Twitter name is @pnoorderijk. I would like to excuse me in advance for my English. My native language is Dutch, so sometimes I need to think about some English words. Sorry for that, but I try to do my best to make it all the best. Okay, well, let's go to some technical stuff. HyperV in Windows Server 8 is the third version of HyperV. Started in Windows Server 2008 with HyperV 1. It was a really basic hypervisor, and it does not have enterprise features, and that doesn't make it enterprise ready. HyperV version 8 is followed by HyperV version 2 in Windows Server 2008 R2, and there were some interesting new features in the version, such as clustered shared volumes. And with clustered shared volumes, we do not have the limitation anymore of one virtual machine per run. And with Service Pack 1 in Windows Server 2008 R2, there is also a big improvement with dynamic memory and remote FX. And what we see is that HyperV is becoming a better and better hypervisor, and we see that it's now enterprise ready. When we take a look at HyperV version 3, that's the version in Windows Server 8, we see that's a really fantastic hypervisor, and that it's a step ahead of the competitors. Well, we did not have time to discuss all the new features or improvements of HyperV in Windows Server 8, and therefore we take three subjects where we would like to talk about in this webinar. First of all, we're gonna take a look at the storage improvements. After that, we take a look at networking, and last but not least, we take a look at those as the recovery options, and then especially to HyperV Replica. Let's start with the storage subject. I think that you all know that Microsoft is using VHD for virtual hard disks since Microsoft's acquisition of Connectix and their use of Virtual PC in 2003. And Microsoft promised us in 2005 that it will improve the VHD format, and it will come with a better virtual hard disk format than VHDX. And it was needed because VHD format had some limitations, and we need some improvements in the virtual hard disk because we will use it more and more extensively. It's the default disk format for HyperV since the first version, and since Windows 7 and Windows 2008 R2, we see some VHD improvements, but not everything that we want. One of the improvements is that we have native VHD support in the operating system. And this means that we can copy or create a virtual hard disk within a running operating system, for example Windows 7, and that we can place an operating system inside the VHD, and we can boot from the VHD without the need of the operating system. So that was an interesting feature, especially for lab and test environments. One of the big limitations of the VHD virtual hard disk is that it has a maximum size of 2 terabytes. Well, in HyperV 3, Microsoft comes with a new virtual hard disk format, and we call it VHDX. This virtual hard disk format is not supported by earlier versions of HyperV, and you cannot connect a VHDX hard disk to a VM which is hosted on Windows Server 2008 R2 or earlier. But you can convert it to VHD and back to VHDX. And through this method you can still connect data from a virtual machine which is running in HyperV Server 3 to HyperV Server 2 host. What is not supported is that you create a VHD parent disk with a VHDX child or differencing disk. This way of configuring virtual hard disk is not supported. The speed of VHDX is much faster than VHD files, and that's because they eliminate the alignment issues. They can align in blocks of 1 MB till 265K, and that's a huge improvement when we compare it to the VHD file format. We have a new block size of 32 megabyte for fixed and dynamic disks, and 2 megabyte for differencing disks. The block size in the previous versions was 2 megabyte. And then the maximum size of the VHDX virtual hard disk is 64 terabyte for now. Another improvement is clustered shared volumes version 2. Clustered shared volumes were introduced in Windows Server 2008 R2, and as I said earlier, it eliminates the need for the 1 VM per LAN configuration, which was the case in Windows Server 2008. A clustered shared volume is a kind of clustered file system, but it does not work with SCSI level locks, so it's not a real clustered file system, but it's a kind of. It's just an NTFS file system, and it makes it possible to write and read from more than one host to a single volume. So this makes it possible that you create a cluster, create a clustered shared volume, connect a clustered shared volume to the cluster, and place virtual machines on the clustered shared volume, and that virtual machine can be hosted by all the hosts in the cluster. But clustered shared volumes have some limitations, and it also needs some improvements. One of the limitations is that you cannot monitor a clustered shared volume because it is not presented as a file system to Windows. When you create a clustered shared volume, you only see in the previous versions, you only see that clustered shared volume in your cluster manager and not in your disk manager. So that's changed in the new version of HyperV. You now can see it as a file system within your disk manager, and you can now monitor it through, let's say, System Center Operation Manager. So you can now monitor the free space on the clustered shared volume. Another advantage is that you now can manage it with PowerShell, and that you can create, manage, and edit clustered shared volumes from out PowerShell. In previous versions, cluster chat volumes were only usable in HyperV and not in other server roles, and that's not valid for Windows Server 8. You can use cluster chat volumes for HyperV, but also for, let's say, the file server role. Cluster chat volumes is now multi-subnet supported, and this means that you can place different cluster chat volumes in different subnets, and this makes disaster recovery scenarios more easier. And this also gives you the possibility to spread your SANs through more than one location and the location is divided into different subnets. That's no problem for HyperV anymore. It's more easy to add storage to a cluster chat volume. Microsoft made an intuitive wizard within the cluster manager from where you can add storage or free space to an existing cluster chat volume. You just select some hard disks or some free space within a hard disk, start a wizard, and add those spaces to a cluster chat volume. Cluster chat volume is integrated with SMB multi-channel, and this means that it can transmit I/O traffic through more than one network interface card. It can use several network interface cards for transmitting I/O traffic to the SAN or to another host. There are some improvements in I/O performance when a cluster chat volume is in redirection mode, and this happens when you need to make a backup of a cluster chat volumes or from virtual machines on a cluster chat volume. Because cluster chat volumes work with a coordinator node principle, they need to take ownership of a cluster chat volume when a backup comes in place. And this means that other hosts in the cluster cannot access the cluster chat volume through the storage connection anymore. They need to redirect their I/O traffic through a network connection to the coordinator node, and the coordinator node pairs the I/O traffic through the cluster chat volume and back. And that's a big disadvantage of cluster chat volume version 1, because you pay a huge performance penalty when this happens. And sometimes this also happens throughout the day. We see a lot of complaints about cluster chat volumes I/O redirection, and what I've seen is that it is very much better in Windows Server 8. The performance is better, it uses SMB, so I/O traffic is faster, and this makes I/O redirection more suitable for day-to-day operations. Last feature is that you have the ability to scan and repair volumes with 0 offline time. Cluster chat volumes version 1 needs to be offline when you repair them or when you would like to defrag them. And that means that all the virtual machines on that volume must be migrated to another volume, or that you must bring down those virtual machines. With cluster chat volumes version 2, you can do maintenance while the virtual machines remain running. So that's a big improvement. So let's recap and look at some other improvements. HyperV in Windows Server 8 gave us live storage migrations, and that was not available in earlier versions. And this means that we can move virtual machines from one cluster chat volume to another cluster chat volume, or to file share on a server without any downtime. And yes, you hear it correct. We can place virtual machine files on file storage on a file server. So you can create a file share on a file server, create a virtual machine within HyperV, and place the virtual machine files on a file share. Communication between the Hyper-V host and the network file server is through SMB, and this file server must be Windows Server 8. Hyper-V in Windows Server 8 does also support guest fiber channel, and therefore we can apply virtual machine guest clustering. So we can create virtual fiber channels within a virtual machine, and via that way we can create application clustering through Failover Cluster Manager within a virtual machine. And that we can do that via iSCSI, and in Windows Server 8 we can also do it via fiber channel. Live VHD merge and secure copy offload are interesting features when you do maintenance in your environment or when you're playing around with a lab environment. Secure copy offload is also interesting when you have a data center in at a location which you do not trust at all. Go back. Okay. When we talk about the good, the bad, and the ugly, NIC teaming and maybe whole networking stack in previous versions of Hyper-V is, from my point of view, the ugly. That's because it is missing some features which we absolutely needed in an enterprise environment, but also in a medium-sized environment. One of the things I don't like is that Microsoft does not support NIC teaming from the operating system itself. They say that when you would like to use NIC teaming, you need to get your support from your hardware vendor. And this means that when you have any troubles with a virtual switch or with network components within a Hyper-V parent partition, you always first had to break up your team, reconfigure your network interface cards, and then you can call Microsoft for support. Excuse me. This is not an ideal situation, and another bad thing is that it is hard to configure. You cannot mix up network cards of different types or with different driver versions into one NIC team. Sometimes it will work, but in the most cases it gives a lot of problems, and especially when you use that team for a virtual switch connection. Another thing I don't like is that there is not a common manual which tells you how you need to configure teaming within Hyper-V, because we need to get support from our hardware vendors. And HP tell us that we need to do it in another way than NEC will tell us, or that Siemens will tell us, or that Broadcom will tell us. So there are many different ways to configure NIC teaming within Windows Server 2008 R2. And there were a lot of complaints about that. And Microsoft hear that complaints, and they are working on a solution. And when we again looking at the good, the bad, and the ugly, I can say now networking is a good one in Hyper-V in Windows Server 8. It does support NIC teaming as a native OS feature. So NIC teaming is possible through the operating system itself. Within Server Manager, you can create a NIC team, and all the NICs that are supported by Windows are supported in a NIC team. It's very easy to configure because they have made some wizards in which you can select the different NICs which you would like to involve in your team, and the team is creating by a very easy wizard. You can mix up different types or drivers within one team, and this means that you can mix up network interface cards from Intel or Broadcom or HP or NEC, or call it something, into one team. And you can also use different driver types within one team. I have tested with 4 different types and 4 different drivers. And I could create a team with 32 NICs. So that was really impressive. Another new feature in Windows Server 8 is that we get an extensible vSwitch. And an extensible vSwitch means that third-party vendors can plug into this virtual switch with their own operating system. When we, for example, take a look at Cisco, Cisco made an iOS for an HyperV virtual switch. And this means that the Cisco iOS runs on the HyperV virtual switch and that you can use all options that are available in the Cisco iOS. There are some other vendors like Five9, for example, which make firewall extension for the virtual switch of HyperV. And with this option, you can create a very secure and manageable virtual switch. Native from out the operating system, you can configure port ACLs, access control lists, and VLAN ACLs within a virtual switch. So the virtual switch is extensible, more secure, and better manageable. When you choose NIC teaming and when you configure it, you can do load balancing and failover. So when a NIC of your team becomes offline, automatic failover took place. And when all the NICs are online, you can apply load balancing throughout over the virtual NICs. Over the physical NICs. It's also possible to aggregate bandwidth. So if you have 4 network interface cards and every network interface card has a speed of 1 gigabyte, then you can create a team of 4 gigabyte interface. And this is very interesting when you configure an iSCSI connection, for example. So you can aggregate more NICs so that you create a 10 gig team and use that 10 gig team for your iSCSI connection. We have multiple modes and you can choose between switch dependent and switch independent. With switch dependent, it's needed to connect all the NICs within the same team to the same physical switch. And with switch independent, you can create the physical NICs to different physical switches. Then we can, outbound traffic can be distributed among the available links in many ways. And one rule that you should be followed is that you try to keep all packets associated with a single TCP stream in a single interface. By doing this, you minimize the out of order of packet arrival scenarios. And traffic distributions can be configured in 2 ways. We have HyperV switch port way and the address hashing way. And Windows Server uses the HyperV switch port as the identifier rather than the source MAC address when you choose the HyperV switch port way. There will be a logical connection through the HyperV virtual switch port and the physical NIC in your host. And when you pass traffic out to the host, it will follow the same route back to the virtual machine for the same traffic. The other way is address hashing, and when you choose address hashing, you have 3 options. You can choose for source and destination MAC address hashing, source and destination IP address hashing, it's also called 2-tuple hash, or you choose source and destination TCP ports. And the last one, source and destination TCP ports, is only you can only use it when you have pure TCP or UDP based network traffic. The NICs within your team can be configured to be active, and active standby. So you can configure a team of 4 NICs and make them all active and 1 standby, or whatever you want. So when we look at this table, I have summarized the different switch types, so the switch independent and the switch dependent type, and I have write down the address hash mode and the HyperV port mode. This slide is some information for you when you look the webinar back. It's not mentioned for now to figure this all out. The next topic we talk about is disaster recovery. And before Windows Server 8, it was a very expensive solution when we will arrange disaster recovery, and that's because you need some very expensive hardware and software to arrange, for example, storage replication. First of all, you need a high-end SAN, and that SAN must be suitable for storage replication. Although the hardware is available and the hardware is capable to do it, most vendors ask you kindly to pay for a license which makes storage replication possible. So that are expensive costs, and you also need a huge bandwidth connection between the 2 data centers for replication to occur. The second thing is that it can be very hard to configure and administer the storage replication, because it's a process that's running for days and months and weeks and years, and you constantly need to check if the data on your disaster recovery site is accessible and if it is mountable, and you need to create test plans for your disaster recovery site to examine that the replicated storage is that okay to start virtual machines, to create your HyperV cluster again on, and to bring up that virtual machines in that way that it was running in your primary data center. So it's expensive, it's hard to configure and administer. Well, in the next version, we got a very cool solution, and I think it's one of the best improvements since NT4, and that's HyperV Replica. HyperV Replica gives us the possibility to replicate a virtual machine through another host, and that host can be in the same data center or in another data center. And when that host is in another data center, it also can be in another Active Directory site. So the host to which you replicate your virtual machine does not need to be part of your own environment. And this gives you the possibility to replicate virtual machines to, let's say, a service provider or a cloud provider, and use their data centers as your disaster recovery site. HyperV Replica is a built-in software-based asynchronous replication mechanism, and that means that it's working as follows. When you enable HyperV Replica, every change in the virtual machine and every write action is write to a log file, and that log file is updated every 5 minutes. So all changes are writing to a log file, and that log file is shipped to the host on which the replica is running, and then it's committed to the virtual machine that is running over there. I would point that HyperV Replica is a disaster recovery solution for small and medium business. And that's because it is using a lot of bandwidth for replicating changes in the virtual machine. And it's not a solution for replicating hundreds of virtual machines to another data center. When you would like to replicate those amount of virtual machines, you still need storage replication and a dark fiber channel connection to your other data center. When you replicate virtual machines to another server, you can choose between two authentication methods. You can use Kerberos authentication, or you can use a certificate-based authentication. Please use Kerberos when you are replicating your virtual machine to a host within your own Active Directory environment. And you should use certificate-based authentication when you replicate your virtual machine to a host which is not part of your own Active Directory. Please be aware that it's not clustering. And I say this because many people think, hey, HyperV Replica does eliminate the need for an HyperV cluster, and this is so not true, because you cannot fill over HyperV VMs within a couple of seconds to another host. It's not clustering at all, and in a bad case you can lose 10 minutes of data because of the 5-minute time it needs to update the log files of the HyperV Replica machine. When you would like to enable HyperV Replica, you do not need an HyperV cluster. So failover clustering is not needed to enable HyperV Replica. And then we take a look at the scenarios. You can replicate a virtual machine from a standalone host to a host in a cluster. You can replicate a virtual machine from a cluster host to another cluster host, or from a cluster host to a standalone host. And imagine that you have a virtual machine of a couple of 100 gigabytes with data. Then you do not want to replicate those data through your LAN or WAN connection to the host which is hosting your HyperV Replica. And there is a solution for. You can do your first replica, your initial replication to an offline media, let's say a USB disk or a SAN disk or a NAS disk or whatever. You can do that first replica to the offline media storage, and transport the storage to the host in the other data center, connect it, import the replica, and then HyperV sees the replica and immediately starts replicating the changes that took place between the initial replication and the import of the replica. And last but not least, I would address the last point. Think about your page file. The page file is a file within Windows with a lot of write actions. And every write action is monitored by the HyperV Replica process. And this means that you will have a lot of replication traffic when you also replicate the page file to another host. So the recommendation is, when you make use of HyperV Replica feature, that you create a separate hard disk for the page file, place the page file on that dedicated hard disk, and exclude that hard disk from HyperV Replica. HyperV Replica is completely managed through the HyperV Manager or through PowerShell. So with this last point, I will end up my slides.